Earth is wearing an invisible shield right now, and it's cracking over an area nearly the size of Europe. Scientists just confirmed it's happening faster than anyone predicted, and if it fails, everything with a battery, a satellite, or a heartbeat could be in danger. Right now, above your head, an invisible force field stretches 65,000 kilometers into space. You cannot see it, you cannot feel it, but without it, you would not be alive to hear this sentence. This is Earth's magnetosphere, and it is under attack from a star 93 million miles away. Here is what most people never learn in school. The sun is not a calm, glowing ball of light. It is a violent, churning nuclear furnace that constantly fires a stream of charged particles into space. This stream is called the solar wind, and it travels at speeds of over 1.5 million kilometers per hour. If this wind hit Earth's atmosphere directly, unfiltered, it would strip away our air the same way it stripped away the atmosphere of Mars billions of years ago. Mars once had rivers, lakes, and possibly oceans. Today it is a frozen, radiation-blasted desert. Scientists studying Martian rock samples confirmed that Mars lost its global magnetic field roughly 4 billion years ago, and within a few 100 million years, the solar wind peeled away most of its atmosphere into space. Earth is not Mars, and there is one reason why. We have a magnetic shield, and Mars does not. So where does this shield come from? Deep beneath your feet, roughly 3,000 kilometers down, lies Earth's outer core. It is not solid rock. It is a swirling ocean of molten iron and nickel, spinning and churning under immense heat and pressure. This constant motion of liquid metal generates electric currents, and those currents generate a magnetic field. This process is called the geodynamo, and it has been running continuously for over 3 billion years. Think about that. Long before dinosaurs, before the first fish, before the first single-celled organism crawled out of the ocean, this invisible engine was already spinning beneath the surface, quietly building the shield that would one day make complex life possible. This magnetic field extends far past the surface into a region called the magnetosphere. It acts like a cosmic force field, deflecting most of the solar wind around the planet the same way a river splits around a boulder. Without it, high-energy particles would slam directly into our atmosphere, stripping away oxygen and ozone molecule by molecule. The ozone layer itself, the thing that blocks deadly ultraviolet radiation from frying every living cell on the surface, depends on an intact atmosphere to survive. No magnetic shield means no atmosphere. No atmosphere means no ozone. No ozone means no protection from UV radiation intense enough to cause immediate cellular damage. This is not science fiction. This is basic planetary physics confirmed by decades of space missions. Now here is where this story gets unsettling. This shield is not perfectly uniform. It has a weak spot, and that weak spot is growing. It is called the South Atlantic Anomaly, first discovered by scientists in the 19th century over the region southeast of South America. For over a century, it was a curiosity. Today, it is something space agencies watch closely because new satellite data released in 2025 shows the anomaly has expanded dramatically. The European Space Agency's Swarm satellite constellation has been measuring Earth's magnetic field continuously since 2014. 11 years of data were analyzed by a team led by Professor Chris Finlay, a geomagnetism researcher at the Technical University of Denmark. The results, published in the journal Physics of the Earth and Planetary Interiors, revealed that the South Atlantic Anomaly has expanded by an area nearly half the size of continental Europe since 2014. Let that sink in. In just over a decade, a weak zone in our planetary shield grew by an area you could fit most of France, Germany, and Spain into combined. And it is not expanding evenly. The researchers found that the region southwest of Africa is weakening even faster than the area near South America, with the decline accelerating sharply since 2020. Professor Finlay explained that the anomaly is not behaving like a single uniform block. It is changing differently toward Africa than it is near South America, suggesting something unusual is happening deep in the core beneath that specific region. In numbers, the minimum magnetic field intensity inside the anomaly dropped from about 22,430 nanotesla in 2014 to roughly 22,094 nanotesla in 2025. That may sound like a small shift, but for a magnetic field that normally changes at a glacial pace over decades, this is a significant and measurable decline happening in real time. A separate study published in early 2026 added even more detail. Researchers found that the eastern side of the anomaly, near the 0-degree meridian, lost approximately 600 nanotesla of field strength between 2018 and 2025. Compare that to the western side, near South America, which lost only about 200 nanotesla in the same period. That is 3 times the rate of weakening on one side of the anomaly compared to the other. Scientists describe this as an imbalance, and it points to something genuinely strange happening at the boundary between Earth's molten outer core and its solid mantle, nearly 3,000 kilometers beneath our feet. In fact, one of the most recent papers, released in August 2026, found that instead of magnetic field lines emerging normally from the core in the southern hemisphere, they appear to be getting pulled back inward in this specific region, creating a patch of reversed magnetic flux at the core surface. Why does any of this matter to you, sitting wherever you are right now? Because this weak zone is not just an abstract scientific curiosity, it has real, measurable consequences today. Satellites and spacecraft that pass through the South Atlantic anomaly experience significantly higher doses of radiation because the weaker magnetic field allows energetic particles to dip much closer to the surface than anywhere else on the planet. This radiation can knock out onboard computers, damage sensitive electronics, and in some cases trigger temporary system shutdowns. Space agencies actually plan satellite operations around this region, temporarily powering down non-essential systems on spacecraft while they pass through the anomaly to avoid permanent hardware damage. The International Space Station itself passes through this zone regularly, and astronauts have reported seeing bright flashes of light, essentially cosmic rays striking their retinas directly, at a higher rate when the station crosses this region. Now, before anyone panics, here is the important context that responsible scientists always include. NASA has been explicit that the South Atlantic anomaly creates no visible impact on daily life on the surface for ordinary people, and its current weakening still falls within what scientists consider to be normal variation for a planetary magnetic field over geological time. This is not the plot of a disaster movie. Your phone will not stop working tomorrow. But here is the part that keeps researchers paying close attention. In the deep history of our planet, Earth's magnetic field has completely flipped, north becoming south and south becoming north, on multiple occasions. These are called geomagnetic reversals, and the geological record shows they have happened hundreds of times over Earth's 4.5 billion year history. The last complete reversal happened around 780,000 years ago. Some scientists have proposed that a growing, weakening anomaly like the one we are watching right now could be an early sign that a future reversal is beginning to build, though this remains a genuinely open and actively debated question in the scientific community, not a settled fact. During a full reversal, the magnetic field does not disappear instantly, but models suggest it can drop to a fraction of its current strength for a period that could last centuries. During that window, our shield against solar radiation would be significantly weaker across the entire globe, not just over one anomaly. This raises real questions studied by geophysicists, atmospheric scientists, and space agencies about increased radiation exposure, potential disruption to satellite networks that our entire modern economy depends on, and effects on power grids from stronger geomagnetic storms reaching the surface. To put the economic stakes in perspective, a severe geomagnetic storm hitting an unprepared, modern, satellite-dependent civilization has been estimated by risk analysts and insurance industry researchers to cause damages ranging into the hundreds of billions to over $1 trillion, when you account for satellite damage, GPS disruption, aviation rerouting, and power grid failures across multiple countries simultaneously. This is not a distant hypothetical. In 2012, Earth narrowly missed a solar storm so powerful that scientists later calculated if it had hit us directly, instead of missing by about 9 days, it could have knocked out transformers, satellites, and power grids across large parts of the planet, with recovery estimated to take years, not weeks. This is also why space weather monitoring has become a genuine national security priority for countries like the United States, which now tracks solar activity through agencies including NOAA's Space Weather Prediction Center, treating a massive solar storm with the same seriousness as other major natural disaster scenarios. Our entire modern civilization, GPS navigation, banking systems that rely on precise satellite timing, aviation communication, military infrastructure, and the power grid itself, sits underneath this invisible shield and largely takes it for granted. And here is something that connects this story across billions of years of Earth's history. A study led by NASA researchers found evidence that Earth's magnetic field strength has actually risen and fallen in sync with atmospheric oxygen levels for over 500 million years. When the magnetic field weakens, it appears connected to shifts in how much oxygen the atmosphere retains, because atmospheric escape and magnetic shielding are deeply linked processes. This means the shield above your head is not just protecting satellites and power grids. Across deep geological time, it may have directly shaped whether Earth could sustain the kind of oxygen-rich atmosphere that allowed complex, breathing life to evolve at all. So what should you actually take away from this? Earth's magnetic shield is real, it is measurable, it has protected life on this planet for over 3 billion years, and right now, in this exact moment, one section of it is weakening faster than scientists have ever recorded with modern satellite technology. This is not fear-mongering. This is published, peer-reviewed data from one of the most sophisticated satellite missions ever launched to study our planet. Scientists are not panicking, but they are watching closely, because the next generation of satellite measurements will determine whether this is a temporary fluctuation in Earth's ancient internal engine, or the early signature of something much bigger building beneath our feet. We live our entire lives underneath a shield most of us never think about, generated by a molten ocean of metal 3,000 kilometers beneath our feet, protecting us from a star that could strip away our atmosphere in a geological instant if that shield ever failed. If you found this as unsettling and fascinating as I do, follow this page, because we are going to keep tracking what scientists discover about this growing anomaly as the new data comes in. Now tell me honestly, does knowing this invisible shield is weakening change how you think about the planet under your feet? Or is this something you think we genuinely don't need to worry about?